Your AMA is going to be found the same way as before with the other simple machines. So AMA equals force resistance over force effort. So what is the AMA of the pulley system on the right? Our resistance force is 800. Our effort force, it tells us, is 230 pounds. So 800 divided by 230, my pounds are going to cancel out, equals 3.48. Or 3.48 to 1 would be our ratio. Now, what is the efficiency of this pulley system here on the right? We counted the strands, 1, 2, 3, 4, that is supporting our resistance. So our IMA is going to be 4, and our AMA we just calculated as 3.48. So 3.48 divided by 4 times 100 is 87%. And we can assume that we were losing some of that force due to friction. Let's go ahead and do an example problem. There are two different ways you can find IMA. One of those being the way I just showed you with counting the strands, where you say 1, 2, and the other way is to find it mathematically. IMA equals dE over dr, which equals, right here, our distance resistance is 1 meter, and our distance effort, over here it tells us, is 2 meters. Because when you pull the pulley, whenever you pull the rope on the pulley, it's going to go 2 meters, and the resistance is only going to go 1. So 2 meters. So I know then that my IMA is 2. Alright, so to find my AMA, I know that AMA equals force resistance over force effort. And that equals 80 newtons over 40 newtons. Right, so that's going to be 2. Well, this example made it very easy for us because my IMA is 2 and my AMA is 2. So that means my efficiency would be 100%. But just to do it mathematically, we have AMA over IMA times 100. So that's 2 divided by 2 times 100, which is going to equal 100%. So now let's see what I can find in the garage. Alright, here's an example of a block and tackle pulley. This particular one is used to stretch fences. Okay, there's two different ways that you can find the ideal mechanical advantage for a pulley. One of those, like with a block and tackle, is you're going to count the strands that are actually supporting the weight. Right, so actually connected here to the weight, we have 1, 2, 3, 4. This strand is not connected to the weight. Instead, it's just going up from here over to change the direction. This is an example of what a fixed pulley would be. Right, where if I was just pulling it and this was the only strand connected to the weight, we wouldn't actually have mechanical advantage. Right? Kind of like the same thing, if I only had the pulley here in the back, where it goes up, over, around, that would be an example of a movable pulley, where if I just had 2, and then this one would just be changing the direction. So if I just had 2 strands supporting a weight, we'd have like a movable pulley, and then that would be a mechanical advantage of 2. But I'm using this as our example to find our ideal mechanical advantage. So this one, like I said, I've got 4 strands supporting this weight. It's a boat anchor down here at the bottom. All right, and I've got 4 strands, as you can tell, 1, 2, 3, 4. This one here is just coming up over and changing the direction. So my ideal mechanical advantage for this pulley, mechanical advantage, is 4. And another way that you can find mechanical advantage is if I make a mark right here, and now I'm going to, from that mark, I'm going to pull down, and I'm going to pull it down a foot, okay, to this mark here. Make sure whenever it goes back in. Let me try a little bit more here. Oh, there we go. Hold on. Let me make sure I get to that mark there. There we go. Okay, so that's about a foot. And then I'm going to measure the distance at the bottom. How far from the floor did it raise up? So going down here, kind of steady it a little bit. Yes, it is 3 inches. So it raised from the floor to here 3 inches. And then I had already pre-made the marks of 1 foot, which is 12 inches. So I can do that mathematically, and that comes out to 4. So my ideal mechanical advantage for this block and tackle, this particular one, is going to be 4.